Stone, right before you came in, it was nuking again, and now it's not nuking so much.
My dog was sick.
Okay, there you go.
I was like, this is 11.5.
Right, and the trick always is that I want to make sure you guys are estimating whatever way you want to estimate what the measures are, and then that's the trick with using like a normal piece of paper, 8.5 by 11 piece of paper. Then it gives you kind of an idea of what these things should be. That's why I tried to pick numbers that were. Well, anyway, we'll see. I guess the question is, let's see. You know, the question is how well do fail. That's what you said?
Yeah.
Hashtag fail. That's all right.
Well, this is why my fish are always 2 feet long.
And the more you tell the story, the bigger they get. Right, exactly. So I picked 2 numbers, and the reason I picked 2 is I've never picked 2 before. I usually just do the 3 inches. And as I was writing in that, I often think of you guys, and all my students, and I think, wouldn't it be cool to compare and contrast to see if a slightly longer distance would be more or less accurate, if at all. Maybe it's not meant. Oh God. Oh, he's not sliding. He's rolled. Okay. I saw a truck going backwards. And there's a pickup, and I get nervous with pickups in this weather.
Yeah.
Okay, he's rolling backwards. He's in control. Okay, good. Sorry, my bad. ADD. I just shiny squirrels. So what I want to do is I'm just going to go around the room, and you guys tell me what your 2 measures actually ended up being. So when you estimated 3 inches, Brandon, what'd you get?
2 and 7/16.
2 and 7/16. Beautiful. How about 7 inches?
4.5.
4.5. Love it. Perfect. Good. Let's see if this trend continues. Then.
I got 2 inches and 5 and 7/8.
5 and 7/8. Okay. Cool.
I got 2.5 and 6.5.
2.5 and 6.5. Okay. Good. Good noisy data. I like that.
I had 3 and 2/16.
3 and 2/16.
7.5.
And 7.5? Excellent. Look at that. We averaged. Boom. Got him. Oh, Dave, we'll get you in a second.
I got 2
2
and 5.
and 5. There we go. I would call it a fail. Maybe with a margin of error, Tyler. That's the whole thing, right? It's hard to anecdotally say how we did. I mean, yeah, we can look at it and go, shit, I missed it by 2 inches. And then statistics doesn't exist because with a sample size of 1, there's nothing to talk about. But let's put it all together and see how we did. Yeah, Anna, what you got?
Oh, about 2 1/4.
Uh-huh.
And 4 and 7. 4 and a third. Yeah.
4 1/3.
Yeah, sorry. Couldn't read my writing.
Yeah, what the hell? We'll call it a third. That's good. I give you probably approximately a third. Aaron, you didn't get a chance to do it, right? Not a problem. Dave, what you got?
2 inches. And
2 inches?
4 inches.
And 4. All right. And Chris?
I'm going to bring the average down.
That's
1 and 10/16.
1 and 10/16. Well, actually, you did.
3 and 7/16.
And you did. Well done, sir.
That's my job.
And I appreciate this. Luke, can I get you? I'm sorry, sir. I didn't get you?
No.
Let's get you.
2 and 7/8 and 6.5.
And 6.5. Thank you. So I'm glad that your numbers appear to be what we would call maybe outliers, because it tells us, well, it gives us another opportunity to discuss what to do with them if they are indeed there. If that makes sense. Cool. All right. So what do you think the hypothesis you'd like to test? What do you think? What hypothesis should we test?
People generally underestimate the length of an inch.
Sure, maybe, now good, before we did the data, it would just be, are we targeting an inch properly, or are we not targeting an inch properly? But now that we see the data, if you look at our data, it looks like we might be underestimating how big an inch actually is, yeah? Maybe, because if I tell you to draw 3, and only one person drew a slight bit over 3, and most people were below, and then in 7, we had 1 over, and again, the rest slightly over and the rest below. It looks like we might be underestimating what these measures actually are, yes? Does that make sense? So, what I'd like to do is actually 2 different hypothesis tests, because I don't want to make the assumption. I don't want to make the heart rate error assumption. You guys ever done your heart rate? You ever measured your heart rate? Okay. If you haven't, there's a bunch of ways you can do it. You can do jugular, you can do anatomical snuff box, you can do probably your whatever this down here if you want to. It's probably easiest to do it here. Oftentimes, what people will do is they'll do their heart rate for 10 seconds and multiply it by 6 to get beats per minute. Or they'll do it for 30, multiply it by 2. Or do it for 60, multiply it by 1. because that's a minute, right? And the assumption, if you do any of those, is you get the same BPM. The problem is that you don't, because every one of those is going to have error involved with it. And the shorter period of time, and the larger you multiply it by, you're increasing the error more and more. Think about why that makes sense. Suppose you were off by 1 BPM in 10 seconds. And off is whatever it should be, you were off by 1. You're now going to be off by 6 by multiplying it by 6, because that error gets propagated through the multiplication. Does that make sense? Same thing with the 30, although you'll be off by less, correct? If you're off by 1 BPM in the 30, you're only going to be off by 2, multiplying it by 60, or multiplying by 2 to get the 60. And if you're off by 1 with 60, you're only off by 1. So I don't want to dork with this data at all. I mean, I could, theoretically, divide everything by 3 and divide everything by 7, and then use that as an estimate of an inch. But that's assuming that you guys would have made the same errors over 1 inch as you would with 3 and 7. I'm not sure we would, right? I'm not sure we would. It may have been greater at 1, it may have been less at 1. I was toying with my mind with, maybe I should have them measure an inch and see if they can get an inch. But for some reason, I gravitated to these numbers this morning. I don't know why. So whatever, we'll do 2 hypothesis tests. Do we underestimate? Looks like it's under, right? Underestimate. 3 inches to 7 inches. And Aaron, I thought of you too, because you asked about two-tailed tests last week, and that was the original reason I set this up, was to do a two-tailed test. Not to underestimate, and not to overestimate, but just be wrong in some general way. I didn't want to come in thinking it was going to be too low or too high, but just that it was going to be off in some unknown way. But let's not do that, because it looks like we're off in a very specific way, huh? It looks like we're off because we're underestimating. Let's see if that stands up to scrutiny. Is that fair? I'm sorry if that upset anybody. It was very early. There's a lot of stuff to be talking about two-tailed tests. So I'll just put that on the back burner for now. Cool. Let's do the 3-inch first, and then we'll do the 7-inch and turn it as an in-class quiz. How's that sound? Sound good? Get you guys a quiz in for today? Call it a day that way. Okay, good. So we got a very small sample, which I love. We got a humongous margin of error. That makes me kind of happy to deal with. So first thing I want you to do, get these data into your lists. How about L1, L2? L1 and L2.